Just want to give you a couple of a couple of examples through this video of the worksheets for solving for equations and using a couple of the techniques. So I think you'll find this useful for solving exponential functions. Sometimes you need to use logarithms, sometimes you don't. But let's look here at this first problem. And so I've got to figure out like how can I get these to have the same base? And I know I can rewrite 1 as 4 to the 0 power. And this now they both have the same bases. So I can rewrite this as 2x plus 3 equals 0, 2x equals -3, and x equals a -3/2. So that would be one example of how to do it. Let's go ahead and, here you've already got the same bases. So it's just a matter of saying, oh, well, if that's the case, then I just go ahead and set the exponents equal to each other. And so I end up with 3 equals x because I add 2x to both sides. All right, and I plug that in and I check it. And when I plug in 3 here, I get -3, 5 to the -3, and 5 to the -3. All right, now let's scroll down, do a couple more little advanced ones. So something like, I said 13 is going to be one for homework. So let's go ahead and look at something like -14. All right, and so this is, I want to get all common bases. So 6 looks to be my common base, so I keep the first one and the second one. And the third one now becomes 6 to the -3. That way I'll take the reciprocal and then 2, so the negative sign, and then 6 to the third power is 216. Okay, now because I'm multiplying these, I add the exponents, so I get 6 to the -3x is equal to 6 to the -3. So now I just go ahead and put my exponents equal to each other. So I end up with -3x equals -3, so x is going to equal 1. So I can go ahead and plug in 1 back into my equation, and so I get 6 to the -2 times 6 to the -1, and then again add the exponents, so I get 6 to the -3, which is 1 over 216. So that would work. Okay. All right. And then the next one, again, next one would be if I am using logarithms to solve these exponential equations. Then I'm trying to, as we talked about at the end of class, I'm going to use the log base so that I can end up canceling the log with the base to just get the exponent. So I'm using log base 3 on both sides of the equation. And so this intentionally cancels out, so I just get b. And then it's a matter of solving for, well, what is log base 3 of 17? Well, what do I need to raise 3 by to get 17? And you could use your calculator, and with the change of base formula, becomes log of 17 divided by log of 3. So b is about 2.5789. Okay, just to do number 2, same drill. Now I'm going to do log base 12 of 12 to the r is going to be equal to log base 12 of 13. So this again all cancels out, so I get r is equal to log of 13 divided by log of 12, and I go ahead and plug that in my calculator. Pretty simple because I got the log button there. And the big thing is to remember to do the close parentheses before you hit the division sign. And log 12, and you get approximately 1.03. And this is the approximately sign, 1.032, which makes sense because in order to raise 12 to get to 13, it's just going to be just a little bit over 1. Okay. And then let's do one that's just a little bit more complicated. Number 11 is where I have to isolate. So I isolate my exponent by subtracting 3 from both sides, and then I raise both sides to log base 9, and I go through this process right here. Okay, same drill here. I'm now going to have 11 to n minus 8 is going to be equal to 59. So log 11 of 11 n minus 8 is going to be equal to log 11 of 59. And so I'm going to get n minus 8 is equal to log of 59 over log of 11, which is approximately equal to log of 59 divided by log of 11 and 1.7. So now I go up here and say n minus 8 is equal to 1.7. So n is going to be equal to 9.7. Okay. And again, you can plug that back into your calculator and see if that works. All right, so hopefully you found this useful in getting your worksheets done for async.